Hello everybody, my name is Rashid Laktayi. I'm a second year PhD student at the National Institute of Applied Sciences of University Al Malik Saadi, Tétouan, Morocco. I'm so happy to join and participate in this fourth International Conference of Computer Science and Renewable Energies 2021. Today's presentation topic is about a comparative study of thermal and acoustical insulations used for residential buildings, which is prepared by the two PhD students Rashid Laktayi and Ms. Lamia Al-Harji, and directed by the two professors Mr. Ahmed Khoya and Mr. Abdelmajid Daya. So firstly, let's start by the plan of this presentation. First, I will start by a concise introduction. Second, I will present the model description. Then I will present the results of this work and discussions. And finally, I will present a brief conclusion. As an introduction, the Moroccan building sector requires significant amounts of energy, which constitutes 25% of the total consumed energy, in which 18% reserved for residential buildings and 7% for territory buildings. Nowadays, many tendencies are focusing on studying and developing thermal and acoustical insulations in order to regulate the temperature between indoor and outdoor environments of buildings and to prevent the inward noise. Consequently, that will help the scientists and engineers to choose the appropriate insulators for realizing buildings' thermal comfort and minimize the energy consumption of HVAC, and to choose a good soundproofing to ensure a performant acoustical comfort. The objective of this work is to present a comparative analysis of thermal and acoustical insulations mostly used for residential buildings in Tétouan city. For the model description, the following figure presents the average monthly temperatures in Tétouan city, which is located in the north of Morocco and characterized by a Mediterranean climate. The yearly average temperature is 18.7 degrees Celsius, and the average precipitation is 600.7 millimeter. Moreover, the presented work is focused on stationary regime during summer season, and specifically on the 7th of August 2019 at 2 p.m. This figure presents the four residential buildings envelopes mostly used in Tétouan city. The wall A presents a single layer of hollow clay brick wall. The wall B presents a single layer of concrete brick wall. The wall C presents a double layers of hollow clay brick wall with a medium of polystyrene, and the wall D presents a double layers of hollow clay brick wall with a medium of air. This figure presents the proposed acoustic model, in which we have two separated rooms. The room 1 presents the indoor environment, and the room 2 presents the outdoor environment. While a linear monochromatic source of sound has been placed 1 meter away from the exterior side of each wall, and it is emitted a low frequency sound waves with a velocity of 200 meters per second. The presented walls were modeled and simulated by COMSOL multi-physics software, which is based on finite element method. For the boundary conditions, the simulation is done under the following ones. First, the variation of the thermal and the physical properties is negligible, and an adiabatic condition is assumed along the perimeter of the wall, and finally, the contact between the layers is considered to be perfect. The following figure presents the temperature variations through the walls A, B, C, and D on the 7th of August 2019 at 2 p.m., while the outside environment temperature was 37 degrees Celsius. The outer and the inner facade temperature changes respectively from 32.95 degrees Celsius to 28.15 degrees Celsius for wall A, from 33 degrees Celsius to 29.7 degrees Celsius for wall B, from 34.75 degrees Celsius to 23.85 degrees Celsius for wall C, and from 34.80 degrees Celsius to 23.45 degrees Celsius for wall D, which shows that the temperature variation from the outer facade toward the inner facade are decreased by 40.6% for the wall A, 10% for wall B, 31.4% for wall C, and 32.6% for wall D, which explains that the wall A and B have a weak ability to reduce heat transfer through them, while the wall D presents a good thermal resistance in comparison with the outer walls under study, and that's due to the insulation by air gap with a thickness of 0.06 meter, which gives it a good capacity to block heat dissipation and conserve heating during winter season. During summer season. Moreover, this result is the same as that found by other researchers. The figure on the right presents the variation of the sound pressure level while the sound waves cross the wall A, B, and C and D. We note that the sound pressure level is reduced by 20.4% through the wall A, 21.4% through the wall C, 31.6% through the wall D, and 26.7% through the wall D. These results show that the wall D presents the highest rate of sound pressure attenuation in comparison with the other walls under study. The wall A and C are characterized by the lowest rate of sound pressure attenuation in comparison with the other walls under study, and that's because of the wall A is thin compared to the other walls and to the other walls, and the wall C isn't homogeneous compared to the wall B and D. Finally, as a result, we deduce that the homogeneous and thick walls as walls B and D have proved a good ability to reduce noise transmission in comparison with walls A and C, but their acoustical insulation performances still not good enough. For the correlation, we have observed that despite the performant thermal insulation of certain buildings envelopes, their acoustic insulation performances could be very weak, which could negatively influence the acoustic comfort of inhabitants. For the energy efficiency, choosing the efficient thermal and acoustic insulators still important to ensure a good thermal and acoustic comfort for inhabitants, but the correlation between these two characteristics still quite difficult, while finding correlated models for homogeneous and thick walls of similar structure is possible, and also that helps us to reduce the energy consumption in residential buildings. Finally, thank you very much for your attention, and thanks for the organizers of this interesting conference. Thank you very much.